If there are 200 topographical errors randomly distributed in 500-page manuscript, find the probability that the given page contains exactly 3 errors. Which I think there's some spelling errors in here, which is a little bit ironic, but that's all right. We'll go with it. All right, 200 is the total amount of errors that there are, and we have 500 pages. The only thing we know for sure is that we're talking about an exact amount of 3. We want 3 errors on 1 page. So if there's 200 errors in 500 pages, how many errors are there about per page? So we can say 200 over 500, which gets you to the 2/5, which is 0.4. All right. So that is the average number per page. This is what I'm going to call my lambda. So if I want to figure out the probability of those 3 errors, I'm going to use my formula above, which says that I should have E, and E is just a number. So if you don't have the button E, we'll use 2.7183. If you have E, we'll use it. So we're going to do E raised to the negative lambda. So E raised to the negative 0.4. Then you're going to multiply by 0.4 times, or 0.4 raised to the x, and x is 3. And we'll divide by 3 factorial. So notice we didn't actually need an n here. They didn't give me an n for the overall sample size. So I have just my x and a mean that I can work with. All right, let's try to figure out what we can get for this. I tend to put it all in my calculator at once. You can do either way, pieces of it at a time. If you do it all at once, you got to use parentheses for everything. So I've got E, my E raised to the negative 0.4. E is hiding under the ln button, so second ln.
And how do I get to the factorial?
That's under math.
Under math.
Mm-hmm. And then I want to multiply by, oh, my screen keeps disappearing. 0.4 raised to the third. And we want to divide it by 3 factorial. Does anyone agree with me?
Yes.
What? Oh, you got scientific notation. So it'll just tell you to move the decimal. And the negative number tells you how many decimals to the left to move it. Under math. Math and probability. You can use it, but since it's the only thing in the denominator, it knows that the 3 factorial is what I'm dividing by. But to first safe, no, because it knows that the factorial is an operation, so it's going to do the operation of the 3 first. But if you're worried, you can always put parentheses and it'll still work that way too. All right, so I got 0.007. I'm going to round to 72. Does anybody else agree with me? Yes? So then you would tell me the probability of exactly 3 errors on a page is 0.72%, which is not that large. Questions on the formula? Yeah. Because there's no n, yeah. And I'm measuring like a quantity of errors. So it's like an amount of errors. All right. Now again, this has a nice function as well. The formula is not too bad, but you can use your calculator. It's very similar to the binomial in that exact is used for PDF, non-exact is used for CDF, and you have the 4 cases again. The only difference is you don't have an X. So we're going to go use a Poisson PDF. This asks you for lambda, and then it asks you for your X. So in our case, we're going to put in 0.4, 3, because that's what we have. And we're going to see what it gives us. It's under the same place as the binomial. We just have to scroll down to it. So it's down past the binomial. And then I'm going to tell it that my lambda is 0.4 and my X is 3. Or you're going to put it in parentheses, because that's the other option. And hit calculate. And if we round, we're going to get the exact same number. And don't you appreciate your technology that much more now? Questions on that?